Okay, so what if every single one of those massive ships out on the ocean had, well, a ghost? A virtual ghost, I mean. A digital twin that could help steer it toward a much cleaner, more efficient future. Sounds a bit like sci-fi, right? Well, today we're going to dive into the TwinShip project, which is making this exact idea a reality and using it to tackle the huge carbon footprint of one of the world's biggest industries.
So here's the game plan. First, we'll look at the giant green problem shipping is facing. Then, we'll get into this whole digital ghost ship idea. After that, we'll cover the challenges, and trust me, there are a few. Then we'll see how the TwinShip project is actually building this thing, and finally, we'll check out the payoff, the real-world impact. All right, let's jump in.
Right, so before we can really appreciate the solution, you have to understand the scale of the problem we're talking about. The global shipping industry, I mean, it's an absolute titan of commerce, but wow, it has an equally enormous environmental footprint.
Just take a look at this number. That is a lot of ships. That's the world's entire merchant fleet right there. And you have to remember, every single one of these is a complex machine, running pretty much non-stop 24/7. And that means every one of them is pumping out greenhouse gases that we absolutely have to get under control.
And this right here is why there's so much momentum behind this. It's not just about the environment. There's a huge economic push to make this massive industry smarter and more efficient. We're talking about a market that's going to be worth hundreds of billions of dollars, all focused on using tech to clean up shipping. So yeah, the money's there.
Okay, so how exactly can technology tackle a problem this big? Well, the big idea is to create a virtual, super realistic clone of a real ship. In the industry, they call this a digital twin.
Now, this isn't just some fancy 3D model you can spin around on a screen. No, a digital twin is more like a living, breathing simulation. It's constantly being fed real-time data from the actual ship. Its speed, fuel use, engine strain, everything. So it evolves, it ages, it even gets weathered, just like its physical counterpart out on the ocean.
And this is so cool because it shows you the entire life cycle. The digital twin is basically born when the ship is just a design on a computer. It then follows the real ship through construction, through all its years at sea, through every repair and upgrade, even through retrofitting new green technology, right up until the very end when the ship is scrapped. It's the ship's entire life story, but in digital form.
Okay, so you might be thinking, if this idea is so great, why doesn't every ship already have one of these digital ghosts? Well, it turns out, building a truly accurate twin for a massive piece of machinery that gets battered by waves and storms for decades, yeah, that's incredibly difficult.
So let's break down the specific roadblocks that have been holding this whole thing back. It's not just one thing. It's a really messy mix of tech problems, business concerns, and just finding the right people.
Yeah, this really lays it all out. The problem is a mix of everything. You've got data quality issues. I mean, sensors fail, they get hit by rogue waves, the data gets corrupted. Then there's the business side. Companies are, pretty reluctant to share sensitive stuff like their shipping routes. And then there's a huge skills gap. It's really hard to find people who understand both advanced data science and the nitty-gritty of maritime engineering. It's like all these different experts are in their own silos, not talking to each other. It's a perfect storm of challenges, really.
All right, so that's the mountain they have to climb. Now let's see how the TwinShip project is specifically engineered to tackle every single one of those problems. It's a really smart, targeted approach.
And the heart of their solution is this. It's an open source platform. And that is a huge deal. It means they're creating a shared space, a kind of digital shipyard, where everyone, companies, researchers, engineers, can collaborate and build on each other's work. No more starting from scratch every single time. This table breaks down the key pieces perfectly. So you've got the Vessel AI platform. That's kind of like the operating system for the whole thing. Then there's the Vessel Data Cloud Space, which is a secure, organized place for all that messy data to live. They've also created a set of rules, basically a clear recipe for how to build accurate models. And I love this last one, the System of Systems model. It means they're not just creating a twin of the ship as a whole, but of all its crucial parts, like the engine, the propeller, you name it.
And this is how they deal with what they call extreme data. The messy, incomplete stuff we talked about. It's a super clever multi-step process. First, they filter out the obvious junk. Then, they use AI to find patterns in the good data. And here's the clever part. They use those patterns to spot more subtle anomalies and remove them. Finally, they use smart algorithms to fill in any gaps. It's almost like digital forensics for ship data.
Okay, so you've gone through all that work. You've cleaned the data, you've built this incredibly accurate digital twin. So now what?
what do you actually do with it? Well, this is where the magic really happens.
The twin basically becomes the core of what's called a decision support system, or DSS for short. You can think of the DSS as the twin's brain. It can run thousands, even millions of what-if scenarios. What if we take this route? What if a storm hits here? What if we slow down by 1 knot? It games out every possibility in the virtual world to find the absolute best move for the real ship. And it's not just one brain, it's actually 2. There's an onboard system right there on the ship for the crew. It helps them with real-time, short-term stuff, like finding the most fuel-efficient route around a storm or even figuring out how to use waves to get a little extra push. But then there's a second brain, an onshore system for the company's bigwigs. This one helps with the long-term strategic planning, like which multi-million-dollar green technologies should we invest in for our next fleet of ships. 2 different jobs, 1 digital twin. Which brings us to the bottom line, the most important question of all. What's the actual real-world environmental payoff? Because all this incredible tech is great, but it has to lead to a cleaner planet.
And here it is. This is the big number. In the pilot phase, just by using that onboard system for voyage optimization, they're expecting to cut emissions by 20 to 30%. Let me say that again, 20 to 30% per voyage. That's not a tiny improvement. That's a massive, immediate impact.
And this really puts the long-term vision into perspective. This technology is a crucial tool to help the entire shipping industry hit these critical climate targets. We're talking about a path to net zero by the middle of the century. So you can see, this isn't just about making one ship a little bit better. It's about giving the whole fleet a way to transform itself.
So in the end, the TwinShip project isn't really about one single ship or one company. It's about creating a proven, open-source roadmap that the entire industry can follow. It's about accelerating innovation and, crucially, proving that sustainability can actually be good for business. And that leaves us with a pretty fascinating thought, doesn't it? Could the future of green shipping really be guided by a ghost in the machine? A future where the things we buy, the food we eat, all of it, is carried across the ocean by ships that are smarter, safer, and so much cleaner, all thanks to their own invisible digital twin.